Imagine a massive asteroid or comet crashing into Earth, unleashing a colossal tsunami that reshapes the coastline and leaves behind a permanent scar. This is exactly what happened in North Carolina Sandhills, where geologists have uncovered direct evidence of an extraterrestrial impact and tsunami. The discovery has sent shockwaves through the scientific community, and for good reason. It's a game changer. But here's where it gets fascinating. The evidence is tucked away in a hillside in Moore County, waiting to be deciphered by experts. The team, led by consulting geologist G. Robert Gannis, has identified a unique package of layers that record the impact and subsequent tsunami. This package, dubbed the Mount Helicon Formation, is a mere 1 yard thick and consists of 4 distinct beds, each telling a different story. The first bed, about 17 inches thick, is a dark, sandy clay rich in carbon, glass, and rock fragments, with iridium levels far exceeding typical crustal levels. This is a strong indicator of impact fallout, as iridium is rare in Earth's crust but common in many meteorites. The second bed, roughly 3.5 inches thick, is a silt-rich layer with small agglutinated pellets that resemble accretionary lapilli, which form when ash and fine particles clump together in moist air. The third bed, a 2.4-inch breccia, is a jumbled mix of ripped-up soil and seafloor fragments, while the fourth bed, about 6 inches thick, is a coarse sand layer likely emplaced by a later tsunami pulse. Now, you might be wondering how this discovery is linked to the Chesapeake Bay impact structure, which is suspected to have launched this debris toward the Carolinas. The answer lies in the fact that the site lies about 235 miles southwest of the buried impact structure, which is the largest known impact crater in the United States and the 7th largest on Earth. The Paint Hill channel fill makes geological sense in this context, as an impact of that size would have lofted ejecta across the region and sent water surging inland. But what's really interesting is the presence of iridium in the Paint Hill impact area, which is a strong indicator of impact fallout. In fact, one study linked the iridium layers from the Chicxulub impact event, which occurred around 66 million years ago, directly to the Cretaceous-Paleogene mass extinction boundary sections worldwide. Another impact fingerprint is shocked quartz, which forms under extreme pressures. Such grains from the Upper Eocene have been documented in east-central Georgia, strengthening the regional picture of ejecta distribution. The Paint Hill sequence is a remarkable find, with each bed telling a different story about the impact and tsunami. Bed 1 records the first seconds to minutes after the impact, when fine ejecta and carbon-rich debris fell out and settled into the channel. Bed 2 tracks the lingering fallout of finer particles as the plume thinned, while Bed 3 captures the inland surge with a slurry of seawater and sediment tearing up soil blocks from nearby uplands and rolling slabs of older beds into the channel. Bed 4 likely represents a later pulse or backwash that reoccupied the channel and laid down clean sand and a bit of pea gravel. The impact beds cut into an older package of nearshore Eocene strata, which host marine fossils and show repeated fining and coarsening cycles that reflect shifting shoreline conditions along the upper Atlantic coastal plain. Soils at the top of that older unit had time to harden before the impact, which is why chunks of paleosol ended up in Bed 3. This detail means that land in this part of North Carolina was emergent by late Eocene time, then was abruptly disturbed by a tsunami surge. The Paint Hill impact matters because it shows that effects from the Chesapeake Bay impact reached well into the Carolinas, supplying a local marker bed that can help correlate Eocene sections across the region. naming the Mount Helicon Formation gives geologists a common language for this specific impact and tsunami package, improving maps, clarifying sea level history, and setting targets for follow-up fieldwork at similar elevations to the east and south. Impact science thrives on multiple lines of evidence, and here, anomalous iridium, lapilli-like fallout, tsunami-style breccia, and a sandy cap line up in a tidy sequence that matches physics and regional context. Each feature answers a different question about timing and process, turning a quiet sandhill slope into one of the clearest places to read the day an object from space changed the Atlantic coast. And this is the part that will spark debate. The study's findings have significant implications for our understanding of impact events and their effects on the environment. But here's the question. What do you think is the most significant implication of this discovery? Do you think it's the fact that the impact reached as far as the Carolinas, or the fact that it provides a unique window into the Earth's history? Let us know in the comments. The study is published in Southeastern Geology, and we'd love to hear your thoughts on this groundbreaking discovery.